Okay, in this video I'm going to go over a couple of neat features of dot and cross products. So these are some like applications of them that you'll see on some test problems. So here we go. This first thing relates angles and dot products. So angles and dot products. So we have cosine of theta. This is a formula that you need to memorize. Cosine of theta is equal to A dot B over the magnitude of A times the magnitude of B. Now these aren't absolute value signs, these are magnitude signs. Magnitude of vector A is equal to the square root of A1 squared plus A2 squared plus A3 squared. And if you have larger vectors, like with 4 components or 5 components, it just keeps on going out, plus a whatever component that is squared. It's basically like a 3-dimensional distance formula in this form. So this is something that you need to memorize for your tests. But this does lead to an interesting fact that if A and B are perpendicular, that means that cosine of 90 is equal to A dot B. Or this really should say cosine of pi over 2 is equal to A dot B over the magnitude of A times the magnitude of B. Now, we can look at this and say, well, the cosine of pi over 2 is 0. So that means that 0 is equal to A dot B over the magnitudes of both. Well, if 0 is equal to this, well, this thing on the denominator can be cross-multiplied, so A dot B is equal to 0 if and only if, and you'll see this abbreviated somewhere as IFF, so if and only if IFF A and B are perpendicular. And they may use another word like orthogonal or normal, and they mean essentially the same thing. They meet at right angles. So if you have a dot product that's equal to 0, then the two vectors are perpendicular. Now, another important feature, this one relates to cross products, and that is the magnitude of the cross product is equal to the, or is equivalent to, the area of the parallelogram formed by A and B. So what does this mean? Well, we can look at it this way. Here is our origin, and we have A going out this way, and then we have B going out this way. You can think of these as points that make up a parallelogram. It comes out like that. Now we have the cross product, which is a vector perpendicular to both, coming up like that. So it's perpendicular to both vectors. Now, this, the magnitude is equivalent, so the units won't match up, but the number that is attached to the units will, is equivalent to the area of this parallelogram here. So you can also use this to find, I'll take away those dash marks, if you wanted to find the area of this triangle, like that, well, that's simply half of the dot, or half of the cross product. So A cross B over 2 is equal to the area of the triangle. So this is another interesting feature of cross products, and that will show up often in linear algebra. So I will now see if I can work a problem regarding this. So come up here and say, okay, so we want to find the angle between, we'll say the vectors -2 and 1 and 5 and 2. So find angle. And I'll abbreviate angle as theta. Well, we remember that cosine of theta is equal to the dot product. We'll call this A here, and this one B. A dot B over the magnitude of A times the magnitude of B. So cosine of theta is equal to, the dot product would be -2 times 5 is -10 plus 1 times 2, that would be 2. So you have -8 over the magnitudes of A and B. So the magnitude of A is equal to the square root of -2 squared plus 1 squared, which would be square root of 5. So we have square root of 5, and the magnitude of B is equal to the square root of 25 plus 4, which would be the square root of 29. Again, this is just 5 squared plus 4 squared. So times the square root of 29. And then, of course, theta will be equal to theta will be equal to inverse cosine of -8 over the square root of 5 times the square root of 29. And this is, if you don't have your calculator, you leave it like this because we can't really simplify it. And if you do have your calculator, you punch it in and get your angle. So this is the answer here. Now, we could do another problem. This one would implement the cross product, and go this way. We have find the area of the triangle with vertices at, we'll call this point 2, 1, 3. Point Q is 1, 0, and 2. Well, it looks like I'm about out of time. I'll save this problem for another video, and I'll do that later. So go and watch the next video.